You've probably heard of the word router. Every framework has one, including React. So, what is a router, and why does everybody need it? Well, we're actually looking at the answer right now. Take a look at the address box. It says we're at the home page. Well, the truth is, there is no real page here. Everything the browser shows is created by components, which means what looks like a page is actually a collection of components. The path decides which components should be loaded. So, if we set a new path, new components will be loaded. As a result, it looks like we have opened a new page. To make this happen, we need somebody to help us change components based on the new path. And that somebody is the React router. For historical reasons, the current version of the React router has 3 modes, and we recommend the data mode. Learning your first router can be challenging because you have to face lots of new concepts. Besides that, the Reactor router offers lots of flexibility, which can be confusing because there are so many options. But don't worry, you are in good hands. I will avoid confusion at the very beginning and show you perspectives and tricks you won't find elsewhere. I mean what I said, because you will find proof within the first few minutes of the next lesson. As you can see, I have created a new React project, and will learn the React router using it. I want you to know every bit of the program, so everything will be created from scratch. The first thing we do is to turn on the terminal. The current project doesn't have the React router yet, so we need to install it. The command is npm install React router. Don't miss the hyphen between React and router. Since we're installing packages, let's also get Axios. And yes, the React router can exchange data with the backend API. The first thing we do is to remove the app component because installing it is now the job of the React router. Next, we import 2 methods from the React router. The first one is createBrowserRouter, and the second one is routerProvider. As suggested by their names, these 2 methods build the foundation of the React router. We put routerProvider inside the render method. RouterProvider is actually a component, and it has a prop called router, which plays a key role. Next, we call createBrowserRouter and pass it an array. Now we have created a new data router. We save the returned value using a constant and pass it to the router prop. Now we have set up a React router. Let's save the file. We can see the page remains blank. The reason is we haven't set any routing rules yet. So the React router doesn't know what to do with the current path, so no components will be loaded. This array is where we specify the routing rules, meaning this is where we tell the React router which path should load which component. Every element here is an object, which is known as the route object. The first property we set is path. Here we set it to /, which represents the route path. The next property is component, and its initial letter should be capitalized. This is where we specify the component name. We set it to app. Now, if we visit the route path, React router will load the app component. Let's save the file. We can see the app component has been brought back. Now we have completed our first route object, and it works perfectly. It enables the route path to load the app component. This, however, does not mean we have learned enough to move on to the next topic. We add a second route object. We still set its path to /, the same as the first one. For convenience purposes, I will use the element property here. It allows us to directly set HTML tags. This way, I don't have to create another component. Now we have 2 identical routing rules. So what would the React router do? The solution is simple. The first one wins. We can see after we have saved the file, the page still shows the app component. To further prove our point, let's reverse the order. Now the page shows the headline because it comes from the first route object. There are only so many paths we can define. So, what if users visit an undefined path? Let's find out. We can see this undefined path has triggered an error. But lucky for us, this error has also told us the solution. It's the error element property. We add error element and assign a headline to it. Now, our custom error message has been presented to users. Usually, we want a more refined error page. In this case, we can create a dedicated component for it. We name the new component Error Page. Now we have the space to set a more refined error page. We import the error page component. Then we remove the headline and add error page instead. Now, the undefined path will load the custom error page. Here comes another problem. Users don't want to stay at the error page, so we should give them an easy way out, usually back to the home page. The React router has thought of this and offers us an excellent solution. We go back to the error page component. We import the link component from the React router. Then we install it in the template. The to prop specifies the target path. Here, we set it to /. Now we can easily return to the home page. The link component will be rendered into an A tag, but unlike the native A tag, the link component won't reload the page. Instead, it will load new components and remove unneeded ones. So always choose the link component over the native A tag. Considering this is our first React router lesson, it's best we only take small steps. Therefore, we won't learn anything new for the remaining half of this lesson. Instead, we'll practice and apply what we have learned. We add a second route object. We set its path to /gallery. Then we bind the new route to a component of the same name. Next, we define the gallery component. First, we import the link component from the React router. We add the link component to take us back to the home page. In the end, we give this div a basic style. We import the gallery component. Then we assign it to the gallery path. Next, let's visit the gallery path. We can see the gallery component has been loaded successfully. At this moment, our demo project is quite simple. But even so, it has already made the main file quite crowded. Therefore, a better solution is to create a dedicated file to manage all the import statements and route objects. We name the file router.jsx. We first import create browser router. Then we paste the copied code. In the end, we export the router object. Now, in the main file, we no longer need create browser router. All we need is to import the router object, and that's it. In the following lessons, we'll continue to work with the gallery route. In this lesson, we'll learn an important topic, the nested route, also known as the child route. The syntax is simple. We add the children property and set its value to an array. This array is the same as the outer one, where every element is a route object. We set path to child. Notice that there is no slash before child. This is because the path of a child router must be a relative one, so it cannot start with a slash. For convenience purposes, I'll use the element property and set a headline. Now we have created a child route for gallery. If we visit it, we'll get two components, the headline and the gallery component. The relationship between these two is also parent to child, meaning the headline is a child of gallery, which means that it should be nested in gallery. So how do we make this happen? In the gallery component, we import outlet from the React router. Outlet is a built-in component of the React router. Its job is to receive and display the component loaded by the child route. We put it in the middle of the template between the two separating lines. Let's try the child route. We can see the child route works. The headline is now nested in the gallery component. Next, let's practice what we just learned. We add another route object, setting a new child route. We name it image. Then we set its component to image as well. Next, we define the image component. I will borrow the two images from the app component. Now, the image component will display the two logo images. We import the image component and assign it to the image path. Let's add image to the current path. We can see the image component is now nested inside the gallery component. Simply put, the child route lets us load multiple components together, including the component of its own and the one of its parent. The React router is quite flexible with the path property. For example, we can remove the gallery path and only keep image. Yes, the page has failed, but don't worry, it's not a big deal. Gallery is no longer a defined path, so it's the reason the page failed. Let's remove it. Now, everything is back to normal. What you just saw is a special type of nested route, the layout route, where the child route alone loads the component of itself and that of its parent. Here's another perspective to view what we just saw. If a component does not have its own path, but has at least one child path, then it becomes a layout. It will be inherited by its child, and it doesn't leave any footprint in the address box. The opposite also works. We disable component, but enable path. Now, gallery is a valid path, but it doesn't have a component of its own, so the page remains empty. Let's add its child path. We can see the image component has been loaded. At this moment, gallery has become a prefix route. Its only job is to decorate the URL, making it more readable. This also means it's not that important, so we can make it optional. We add a question mark behind gallery. This marks that gallery is optional, so its child route can be accessed with or without it. Let's bring back the gallery component. Now, gallery can either be a layout that's invisible in the URL, or it can be a normal component with its own path. One last summary. The child route loads the component of its own and the one of its parent. The child component is nested in the parent via outlet. In this lesson, we'll learn something even more important. You probably have seen things like this. The URL has two special segments. The first one is a key name, and the second one is a value. This is known as the dynamic route, where data is embedded in the URL, and this embedded data is often used by the page below. And yes, the React router supports the dynamic route. The dynamic route needs to be defined as well. We need to tell the React router which segment is the dynamic part. I'll still use the image route as the demo example. We give it two extra segments. The dynamic segment is marked by the prefixing colon, and the name behind the colon is the key name. This segment is also known as the dynamic parameter. We can see the dynamic route has taken effect. The preceding segment can be made optional because it's just a prefix that makes the URL more readable. The next question is how to send the dynamic parameter to the component loaded by it. Let's go to the image component. We import a new hook from the React router. It's called useParams. As suggested by its name, this hook lets us use the parameters of the dynamic route. We call useParams inside the image component. This hook returns us an object that contains the key value pairs of the dynamic parameters from the current URL. We save this object using a variable called params. In the template, we add an h1 tag. We output params.id. ID is the name of the dynamic parameter. We can see the image component shows 1, proving our program works. If we set a new ID value, it will be sent to the image component automatically. Here comes a problem. Users can edit the URL however they want, which means they might submit an illegal value. Therefore, all dynamic parameters must be validated first. We check if the ID value is a number or not. If not, we return an error message. Now the illegal ID has been intercepted. Next, let's try the dynamic parameter in a more lifelike scenario. We check the parity of ID and choose from the two images accordingly. We save the selected image using a variable called chosenImage. We only need one image tag this time, and we use it to display the chosen image. In our real-life projects, the dynamic parameter is often used to decide what the component shows. In the current example, it helps us choose from two images. The current ID is 1, so the React logo is selected. Let's set the ID to 2. This time, the Vite logo is selected. Here comes another problem. Changing the dynamic parameter manually is not convenient. So, is there a better way? At the end of the gallery component, we add two extra links, one for the React logo and one for the Vite logo. Now we can switch images by clicking the two links. Here comes another problem. We want the links to tell where we are. For example, the current page shows the Vite logo, so the Vite link should have a different style. In this case, we need to import a new component from the React router. The new component is called NavLink, which is a more capable type of link. Then we replace link with NavLink. We add the style prop. Normally, the value of the style prop is 2 pairs of nested curly braces, but here it's not. We replace the inner one with a callback. This callback returns an object, which is where we set the CSS attributes. This callback receives an object as its argument, and this object contains 3 properties. IsActive is the one we need. It tells us if the current link is active or not. We use it to decide the text color of the link. We can see the active link is now marked by a gray text color, indicating there is no need to click it again. The dynamic route is a very useful feature, and we'll use it again in the following lessons. By the way, there is another way we can embed data in the URL. Any idea what it is? If you don't know, it doesn't matter. We'll learn it in the next lesson. In this lesson, we'll explore the other way to embed data in the URL. Behind the URL, we add a question mark. Then we set a key value pair. This is known as the query string, which is another way to embed data in the URL. Every component in the current page has access to the query string. Let's still use the image component as the demo example. We import a new hook, useSearchParams. Search parameter is another name for the query string. We still run this hook in the image component. Then we output the returned value. The returned value is an array. The first element is an interface, which is created by useRealSearchParams. useRealSearchParams is a web API. It doesn't come from the React router. The size property tells us the total number of the search parameter entries. We recommend you use the destructure assignment to retrieve the searchparams interface. The get method lets us retrieve the value of the search parameter. We can see we have retrieved the value of message. The search parameter is not a must-have part of the URL. Therefore, we should check its existence before we display it in the template. We can see the value of message has been displayed on the page. Next, let's try the search parameter in a more lifelike scenario. In the error page component, we import useSearchParams. The search parameter allows us to pass a more detailed error message to the error page. We can see the custom error message has been shown on the error page. In this lesson, we'll practice everything we have learned. Meanwhile, the program we create will be used in the next lesson, helping us learn the next topic. The gallery route has served its purpose. It has taught us how to set the child route and the dynamic route. Let's create a new route. We set its path to /story. Then we give it a child route. This child route will also be a dynamic one, and we name its dynamic parameter number. Next, let's move to the new route. At this moment, the page is empty because the new route doesn't load any components. We assign the story route to a new component named selectNumber. Next, let's define the new component. Based on what we have learned, what's the first thing we should import? Well, this component is loaded by a parent route, so we should import outlet so that we can display the component loaded by the child route. Simply put, if a component is loaded by a parent route, then it needs to have outlet. Let's also import the NavLink. It helps us visit the child route. First, we display a title. Then we create a simple navigation bar. We set a NavLink and set its inner text to 123, which is the value of the dynamic parameter. Next, we set the to prop. We can use the relative path here. / represents the story route. The child route, however, must be set in full. Then we set the style prop. If the NavLink is active, we set its color to gray. Now the NavLink is done. We make 2 more copies of it, setting 2 more dynamic parameters. Now the navigation bar is done. It helps us set 3 different dynamic parameters. Our next job is to install outlet so that the component loaded by the child route can be displayed right below the navigation bar. Now we have finished the selectNumber component. Next, we go back to the router file. We first import the selectNumber component. Then we assign it to the story route. We can see the selectNumber component has been loaded, and it offers us a navigation bar. The active link will be marked by a gray color. Next, we assign a component to the child route. We name it Number Details. Then we define Number Details. Number detail is a component loaded by a dynamic route. So what is the first thing we should import? We should import useParams so that we can access the dynamic parameter. Let's also import the link component. It helps us return to the parent route. We call useParams to access the dynamic parameter. We must check the dynamic parameter before we use it. Here, we check if it's a number. If not, we return an error message. Then we add a link to take users back to the parent route. Now, the error message is done. Let's work on the template. We add a headline to output the dynamic parameter. Then we add one more headline. In the next lesson, we'll learn how to retrieve external data using the React router. This headline is designed to display the retrieved data. For now, we just put a placeholder text in it. In the end, we add a link to take us back to the parent route. Now we have finished the number detail component. Next, we go back to the router file. We first import the number detail component. Then we assign it to the dynamic route. We can see the number detail component has been loaded successfully. Using the navigation bar above, we can easily set a new dynamic parameter. Here is one more challenge for you. Let's say we only want to load the number detail component when we visit the dynamic route. Any idea how to do that? The solution is simple. We disable the select number component. Now, the dynamic route only loads the number detail component, so we won't see the navigation bar. But here comes another problem. The story route now loads nothing, which is not what we want. We still want it to load the select number component. Any idea how to do that? We add a new child route. We set its path to an empty string. Then we use it to load the select number component. We can see our problem has been solved. The story route loads the select number component. Setting an empty path looks like a hack. Therefore, the React router offers a better solution. We replace path with index and assign true to it. This way, the story route has an index route, which is essentially a child route that leaves no footprint in the URL. By the way, the index route cannot have its own children. In this lesson, we'll learn something new using the program from the last lesson. Currently, we're revisiting the number route, which is a dynamic route. Its dynamic parameter is a number. In our real-life projects, we often send the dynamic parameter to the backend API. Here, we'll use the numbers API. We send it a number, and it returns us a short text about that number. Our goal is to display the returned text. Simply put, every time we visit the number route, we want to send its dynamic parameter to the numbers API and display the returned text. And yes, this job can be done by the React router. We import Axios first. It helps us send requests and process responses. We give the number route a new property, loader. As suggested by its name, this property is for loading remote data. Its value is a function. We name it loadDetail. Next, we define loadDetail. Inside loadDetail, we return the Axios get method. Now, pay attention here. We need to return the get method. Just calling the get method is not enough because the loader property expects a promise. In this case, there is a better way to set the loadDetail function. We redeclare loadDetail as an async function. We add the try-catch statement. In the try section, we await the Axios get method, which sends a request to the numbers API. Now, we have a problem. How do we access the dynamic parameter? Every loader function receives an object, which has a params property. This property gives us access to the dynamic parameter. We save the returned value using a variable named response. Next, we return an object. We name the property detail and assign response.data to it. Response.data saves the text returned by the numbers API. This returned object plays a key role. It will be sent to the number detail component. We'll leave the catch section empty for now. We'll learn how to properly handle the failed request in the next lesson. Now we have completed our first loader. Next, we go to the component side. We import a new hook, useLoaderData. As suggested by its name, this hook lets us use the data provided by the loader. We call useLoaderData. Remember the object returned by the loader function? It will be sent to useLoaderData, which then returns it. We receive the returned object using a variable named loaderData. We empty the second headline and reset it using loaderdata.detail. Now, our job at the component side is done. Let's check the result. We can see our program works. We have successfully received the text returned by the Numbers API. Let's set a new dynamic parameter. We can see the response to the new parameter has been received as well. It looks like everything works perfectly. Or does it? Let's turn on the console table. We can see there is a warning. So what happened? It takes time to receive the response from the Numbers API. Therefore, if we directly visit the number route, there's nothing to display until the response is received. In this case, the React router expects us to provide a fallback element, which is essentially a waiting notification. We have two options, and I'll pick the first one. I set a headline to display a waiting notification. Now, if we directly visit the number route, we'll see a waiting notification first. This notification will be removed once the response is received. To better manage our code, it's best to save the loader function using a dedicated file. We name the new file load_detail. We import the loader function back to the router file. Let's revisit the number route. Have you noticed anything unusual? Let me repeat what I just did. There's a delay. Clicking the link won't take us to the number route right away. We have to wait for a short while. Remember I said the loader function must return the axios_get method? The axios_get method is a promise that takes time to be fulfilled, and the React router will wait for this promise to fulfill before taking us to the number route. This is why there's a delay. Now, you might be wondering, we already set a waiting notification using the fallback element, so how come it didn't show up? The fallback element is designed for the scenario where we directly visit the number route, which means it only shows up when we directly visit the number route. If we visit the number route from elsewhere, the fallback element won't show up. But don't worry, the React router has prepared something even better, the pending UI. We go to the select number component where the navigation bar is defined. Apart from isActive, we have another option, isPending. It indicates if we're waiting to be taken to a new route. We declare a variable, color, and set its value to blue. Then we add an if statement and check isActive. If it's true, we set color to gray. Then we add another if statement and check isPending. If it's true, we set color to green. Then we set the text color using the color variable. Next, we repeat what we just did on the other two links. We can see now the link turns green right after we clicked it, and it remains green until we're directed to the number route. Next, we go back to the router file. We restore the old routing rule. During the pending period, the number detail component remains unchanged. But let's say we want to replace it with a waiting notification. Any idea how we do that? We go to the number detail component. We import a new hook, useNavigation. We call useNavigation and save the returned value using a variable called navigation. Let's console log navigation. We can see navigation is an object. The state property is what we should keep an eye on. Currently, its value is idle. Let's visit a different number route. We can see the moment we click the link, a new navigation object is output, and its state is loading. The moment we're directed to the new route, a new object is output, and its state is idle. Simply put, we check if the state is loading. If yes, it means the link has been clicked and we should output a waiting notification. We add an if statement and check if the navigation state is loading. If yes, we return a new template. We can see the moment we click the link, the number detail component shows a waiting notification. Now, let's talk about how to handle the failed request. The most direct solution is to throw an error. We add an extra character to simulate an error. Next, we go back to the router file. We give the number route a new property, error element. Do you still remember it? We learned it in Lesson 1. We set a headline to output an error message. We can see our custom error message has been presented to users. Next, let's try the second solution. We define another child route. We name it error. We assign the error page component to it. Next, we go back to the loader file. We import the redirect function from the React router. As suggested by its name, this function redirects us to another route. In the catch section, we return redirect. Now, pay attention here. We must return the redirect function. We use redirect to send us to the error route we just created. We can also add the error message. We can see the error page component has been loaded, and it shows the error message. Look at the address box. We have been redirected to the error route. In this lesson, we'll learn a new topic. We create a new route. We name it Action. Action is the name of the topic we're learning. It's similar to Loader but more capable. Its job is to submit our data to the backend API and process the response.
We add the children array and set 2 child routes.
We name the first child Form. As suggested by its name, this route is for collecting data from us. We name the second child Submit. Its job is to submit our data to the backend API. This also means Action requires 2 routes, one for collecting data and one for submitting data. Let's start with the first route. We add the component property and bind it to action form. Next, we define action form. The first thing we do is to import the form component from the React router. We add the form component to the template. It has an action prop. We set its value to the other child route, which is /action/submit. Then we set method to post. Inside the form component, we add an input tag. We set its type to number and name it number as well. This name is quite important. We'll need it later. Then we add a button tag and name it submit. We set its type to submit as well. Now we have completed a simple form. We can submit a number via it. Next, we go back to the router file. We import the action form component. Then we assign it to the form route. Next, we visit the form route. We can see we have an input box and a submit button. Let's try them. The program is only half done, which is why submitting data triggers an error. But look at the address box. We have been directed to the submit route. Now let's work on the submit route. We add a new property, action. Its value is also a function that returns a promise, just like that of the loader property. We name the action function actionSubmit. Now, every time we visit the submit route, the actionSubmit function will be triggered. The action function also receives an object, and this object also has the params property. Meanwhile, it also has the request property, which is actually the native request interface. It gives us access to the user-submitted data. We await request form data. Then we run the get method and pass num to it. Any idea where num is from? Num is the name of the input tag. We save the returned value using a variable named num. Now we have retrieved the value submitted by the input box. To prove this, let's console log num. We can see the value we submitted has been received by the action function. The warning below says we need to provide a component for the submit route. Let's do it. We name the new component actionSubmit. We import a new hook, useActionData. We call useActionData. In the action function, we return an object and put num in it. And yes, this returned object will be sent to useActionData, which then returns it. We receive the returned object using a variable named actionData. Next, we set the template. We embed actiondata.num in the headline. Now the actionSubmit component is done. We go back to the router file. We import actionSubmit. Then we assign it to the submit route. And that's it. Let's test the program. We can see the page has failed. So what went wrong? We're directly visiting the submit route, which means nothing has been submitted yet. In this case, useActionData returns undefined. As a result, the template will try to retrieve the num property from undefined, and this is what causes the error. The solution is simple. We add an if statement and check if ActionData is undefined. If yes, we return another template. We output, "You haven't submitted anything yet." We can see the problem has been solved. There is no error this time. Next, we import the link component. We use it to take users to the form route where they can submit new data. Actually, this link component is not what I want because we have to click it. Is there a more automatic option? One that can take us to a new route automatically? There is. We import a new hook, useNavigate. We call useNavigate. It returns a function that can send us to another route. We name the returned function navigate. We call setTimeout and set a delay of 3 seconds. We call the navigate function. This function allows us to move up and down the history records. For example, if we want to return to the previous page, we pass -1 to it. But here, I'll still use the absolute path. Now, if we directly visit the submit route, we'll be sent to the form route in 3 seconds. The whole process is automatic. Let's save the file and wait. We can see our program works. We have been sent to the form route automatically. Let's submit a value. We can see the submitted value has been sent to the submit route successfully. If we directly visit the submit route, we'll be sent to the form page in 3 seconds. In this lesson, we will complete the program from the last lesson. We go back to the router file. We import Axios. We remove the returned object and add the try-catch statement. In the try section, we await the Axios get method. We return an object and put number in it. Then we add a second property, detail, and set its value using response.data, which is the text returned by the numbers API. As for the catch section, I will directly throw an error. We've already learned how to handle the failed request in the previous lesson, so I'll skip the details here. Next, we go to the Action Submit component. We add another headline to display the text retrieved from the numbers API. Then we add a link to take us back to the form route. Let's test the program. We can see the text from the numbers API has been retrieved successfully. Next, let's repeat what we just did. It takes time to send the request and receive the response. Therefore, we'll be looking at the form page until the response is received. So how do we display a waiting notification during this period of time? We go to the Action Form component. We still import the useNavigation hook. We call useNavigation. Then we console log the return value. Let's make a new submit. We can see the moment we click the Submit button, a new navigation object is output, and its state is submitting. We add an if statement and check if the navigation state is submitting. If yes, we return a waiting notification. We can see the moment we click the Submit button, the page shows a waiting notification, and it will be replaced once the response is received. Before we end, there's one more thing. I'm not particularly satisfied with this form component. So, is there a better alternative? There is, and we'll learn it in the next lesson. In this lesson, we'll learn the better alternative to the form component. First, we disable the form component. Then we import a new hook, useSubmit. As suggested by its name, this hook helps us submit data. In other words, it's the alternative to the form component. We also need the useState hook from React. We create a state value, number. We use it to save the user-submitted data. Then we call useSubmit. It returns a function, and we name this function Submit. Next, we go to the template. We create an input tag first. We set its type to number. Then we add the value prop and assign the number state to it. Next, we add the onChange prop. We call setNum and pass the user-submitted data to it. In your real-life projects, you should check the user-submitted data before passing it to the state setter. Next, we add a Submit button. We add the onClick prop and run the Submit function in its callback. The Submit function helps us submit data, and it has a rather unique syntax. We need to pass two objects to it. The second object plays the same role as the form component does. We add the action property to specify where the submitted data should go. Then we add the method property and set it to post. Now, the second object is done. We move to the first one. This is where we store the submitted data. We set the property name to number and assign the number state to it. Now, pay attention here. The property name has to be number. Any idea why? In the action function, number is what the get method uses. That's the reason. Next, let's try the program. We type in 1 and submit it. And we can see our program works. 1 has been submitted successfully. In this lesson, we'll learn a new type of action. Let's type in a number and submit it. After the number has been submitted, we'll be sent to the Submit page. In other words, the action function causes a navigation, which takes us from the form page to the Submit page. The new type of action doesn't cause a navigation, which means after we have submitted a number, we'll remain at the form page. Before we start, let's first tidy up the router file. We move the action function to a dedicated file. We create a new route object. We name its path Fetcher. Fetcher is the name of the new type of action. It lets us submit data without causing a navigation, which means if we submit a number using Fetcher, we'll remain at the form page after the number has been submitted.
We add the children property and set two child routes.
We name the second child Submit. Then we use it to host the action function. There's no need to set the component property here because this route is only for hosting the action function, and we will never be sent to this route either. We name the first child form. Here, the component property is needed. We name the new component fetcher form. We import a new hook, useFetcher. Then we import useState from React. We create a state value to save the user-submitted data. Then we call useFetcher. It returns an object, and we name the returned object fetcher. For now, we console log the fetcher object. Next, we work on the template. We add an input tag. This input tag is the same as the one from the last lesson, so I'll skip the detail here. Next, we add the Submit button. The fetcher object provides the submit method. And the syntax is the same as before. We still set two objects. The second object still specifies action and method. The first object still saves the submitted data. Now the fetcher form component is done. We go back to the router file. We import fetcher form and assign it to the form path. Let's test the program. We have clicked the Submit button, and we are still at the form page. Let's turn on the console table. We can see the fetcher object has been output 4 times. To make things clear, let's start over. The first fetcher object is largely empty because we haven't submitted anything yet, but notice that it has a state property, and the current state is idle. The second fetcher object shows up after we have typed 1 into the input box, and it's identical to the first one. Next, let's click the Submit button. The moment we click the Submit button, the third fetcher object shows up, and its state has become submitting. In the end, the fourth fetcher object shows up. The data property of the third fetcher object is still empty. Let's check the fourth one. This time, the data property is no longer empty. It contains the object returned by the action function. We add an if statement to check the fetcher state. If it's submitting, we return a waiting notification. Below the Submit button, we check if the fetcher data is empty or not. If not, we output the detail property. Let's test the program. We can see the waiting notification has been shown. The response from the Numbers API has been shown as well. Simply put, the fetcher object alone does everything. It offers the submit method to help us submit data. Meanwhile, it also offers the state property to help us display the waiting notification. Its data property stores the data returned by the action function. In this lesson, we'll learn a new feature that makes our program more efficient. Look at all the files we have imported. To use all of them, we have to visit every route, which almost never happens. In this case, a more efficient solution is to only load a file when that file is needed, and this is known as the lazy loading. We'll use the form route as an example. We lazy load fetcher form component. First, we remove the component property. We add the lazy property. Its value is an async function. We await the dynamic import that imports the fetcher form component. The static import statement is no longer needed. We name the returned value component module. Next, we return an object. The property name is component, and its value is componentModule.default. You must append the component module with default. Any idea why? The reason is the component file uses the default export. Let's save the router file and try the program. We can see the data has been submitted successfully, proving the lazy loading works. Next, let's practice what we just learned. We lazy load the action function. We await the dynamic import. We return an object and put action in it. Now, the action function will only be loaded when it's needed. But there is a problem. We have another submit route, but it has 2 imports. So, how do we deal with situations like this? We replace both of them with the lazy property. This time, we await the promise_all method. This array provides space to import as many files as we need. We receive the returned modules using the destructuring assignment. Then we return an object and set both the component and action properties. Next, we remove the static import statements. Let's test the program. We can see the data has been submitted successfully, proving both the component and the action function have been lazy loaded successfully.